So year 10, we're on to our fourth circle theorem here out of 8. Hopefully you are watching these videos slowly. Hopefully you are pausing and re-watching if you need to. And if you're doing this in class, hopefully it's clear. Here we go. The next claim from me is that opposite angles in a cyclic quadrilateral add up to 180. So as usual, we're going to deconstruct this word by word. Opposite angles, that's the first thing to clarify. In a cyclic quadrilateral, that's the second thing to clarify. I think you're all happy with add up to 180. Here are a pair of opposite angles. Here are another pair of opposite angles. So that should clarify the pairs of opposite angles. Now, each pair adding up to 180 should make a lot of sense to you, because if these two add up to 180 and these two add up to 180, what does the total for that shape make? That's right, it makes 360, which we know is for a quadrilateral. So the question is, what is a cyclic quadrilateral and how do we prove this rule? A cyclic quadrilateral is any four-sided shape, any quadrilateral, where all four corners touch a circle. So I can draw you a quadrilateral which is not cyclic very easily. I can draw one point touching a circle, another point touching a circle, a third point touching a circle, and the fourth point is inside the circle. That is not cyclic. If the fourth point had been not here but out here, it would not be cyclic. They all have to touch. So a quadrilateral where all 4 points touch the outside of a circle is a cyclic quadrilateral, and the opposite angles are up to 180. Well, how can we prove this? We've had one real weapon so far, one real tool we've used, which was our first rule. If you want to have a think yourself, pause the video and give it a try. Some of you should be able to prove this one without any help. So, the rule we've been using is the angle at the centre. So let's construct some angles at the centre. Well, I'm going to need to cut this shape up. Like so. Now this angle here, what am I going to tell you that angle is? I'm going to tell you that angle links to this angle. Okay, I'm then going to make a claim about this angle here and this angle here. Well, these two angles, I'm going to call them X and Y. This angle here would be 2x, and this red angle here would be 2y. The angle at the centre is twice the angle at the circumference. Well, if the angles at the centre here go round a point, they add up to 360. Therefore, 1x plus 1y must be half of that, 180. These two happen to correspond to a pair of opposite angles, and therefore the opposite angles make 180. Now, we didn't just claim this, we drew it from this equation. We know this is a fact, these add up to 360. We just halved this side and halved this side, and this expression here happened to match exactly what we were looking for, which was this add this. It happened to make 180. So that's why we did that step and how we got that answer. What that would mean is, if this angle up here at the top had been 95, this angle here would be 85. It would also mean if this angle here was 70, that this angle here would be 110. Please note the pairs don't have to be the same, but the pairs do have to add up to 180. What I think you need to do is, if you're happy with that, you need to make the notes. If not, please re-watch the video and try again. If you tried it for yourself and got that, well done. Really impressed.